the class. That is a name that we choose. That's the name by which we'll refer to this class for the rest of this program. And it has a colon at the end of it, and which means it starts an indented block, which ends when we de-indent. Inside the class, there are generally two things. There is some data, and this just looks like an assignment statement in the class, x equals 0. And then there is a def. This looks just like a function, and then it starts with a def, has a colon, indents, so that function finishes right there. The difference is this is a method because it lives inside of a class. And so there is no function called party. There's a function called party within party animal class. And we'll talk in a second about this self thing. It is the way that inside this code we refer back to that variable. So this is not actually executing any code. It's sort of remembering the template, defining the class party animal. This is what we call constructing. We're constructing using the party animal template or class. We are making a party animal, and then once we make that, we stick it in the variable an, and then we're going to call this party animal, this party method 3 times, 1, 2, 3. Now this self thing, and we'll take a look at the self ends up being an alias of an, and so you can look at this syntax as just kind of an equivalent of this syntax. It's calling the party method within the party animal class and passing the instance in as the first parameter, and so self ends up being an alias of an each time these are called. Now if we make a different variable and a second object, which we will eventually, you will see that works a little bit differently. And so this syntax is a short version of that syntax. So if we watch how this executes, it starts up here, it just defines it, and then we construct it. And that's what basically constructing it. We know how to construct it because we look at the class and we make a variable x, we make some code party, and then we construct that. That's what the party animal does, and then we assign that into an. And so an is now pointing at that. Then when we call the party method, that basically takes this an and passes it in as the first parameter, which is used as self. And so self.x, which is what we're doing in this line right here, self.x is a variable. X starts out as 0. X starts out as 0 because when it was constructed it was set to 0. So we're in here, an is an alias of self, and now it looks up self.x, which is 0, adds 1 to it, and so this becomes 1. And then we print so far 1. And then the code returns and it goes down and does it again. And x becomes 2. Prints out so far 2, comes back down, and does the last time, calls it again, self.x is 2, add 1 to it and stick it back in, so this becomes 3, and we print out 3. And then the program finishes. And so you can think of this as constructing the object and then associating it with this an variable. Now that we've created this object, we can play around with things we've played around before with dir and type. We use dir and type to kind of inspect variables and types and objects. So we've been using objects all along. This code here says, hey, make me an empty list. Well, it turns out that what we're saying is there is already a list class inside of Python, and we're constructing an empty list, and when we get back this empty list, we're assigning that into x. So x, in a sense, contains or points to an empty list. So then we say, hey, what is in x? What kind of thing is x? Well, it's a list. This is a thing. It's a list type. Lists have list of things in them. And, use append and all the things we've been doing before, they're just objects. And then the dir, if you remember the dir is the capabilities. And there's all these internal capabilities that do things like implement the bracket operator, etc. Those double underscore ones, we can ignore them, although you can even look them up and figure out what they mean if you feel like it. But the methods that we tend to call are in this class. And so things like x.sort, I've always told you that is the sort method within the x thing. And the dot operator is the operator that we use to look something up within an object. And so you've been using this syntax all along. x.sort, dictionary.items, all of those are methods within the corresponding class. If we take a look at this line of code that we've been doing for a very long time, which says, oh, stick hello there into y. It's if I reword that as more OO or object-oriented, what this single quote does says, make me a string object, and put some text in it, and then when that is done being constructed, stick that into Y, right? And so Y now points to a string object that's been pre-initialized to the string hello there. Now that's a long way of saying hello there ends up in Y, but in OO terms we can talk about that. If we do a dir of that, we see a whole bunch of internal methods which have double underscores, and then we see all kinds of methods that we've been using. We've been using methods like upper, we've been using methods like find, we've been using methods like rstrip, right? We've been using these methods, so we go to like y.rstrip, parenthesis. Again, that's a method, that's an object, not a class, it's an object, and that is the object lookup operator. Now if we do the same thing to code that we've built, or a class that we've built, so now we have a party animal class. Remember, this up to here is just definition. Now we construct it and we store it in AN. So AN is a variable that contains an object of type party animal. We ask it what type it is, and it prints out here. It says this is a class, and it's main underscore party animal, and this whole thing here is the underscore main. It's scoped underscore main. But you can see that you have made a new type. You built a type by using this class keyword. And then we use the dir. Remember, dir looks for capabilities. And again, you will see a whole bunch of underscore things. They have meaning. You can look them up. But eventually, you'll see the two things that you've put in it. One is the method party, and the other is the attribute or field x. And again, these are the things that you can say an.x or an.party, because this dot is the object operator, the object lookup operator that says look up in the object an the thing x, or look up in the object an the thing party. Okay? So up next we'll talk a little bit about how objects are created and destroyed. We also call that object lifecycle. Now we're going to talk a little bit about object lifecycle. And what we mean by object lifecycle is the act of creating and destroying these objects. And I've been using this term constructor already. And so when we declare a variable, whether it's a string or a dictionary or a party animal, whether we create them and then they're discarded, and there's all this dynamic memory that comes and goes. And we, as the writers of objects, have the ability to insert ourselves at the moment of object creation and at the moment of object destruction. And we make special functions that we call the constructor, the object constructor, or the class constructor, and the destructor. And we don't actually explicitly call them. They're called automatically by Python on our behalf. And so the constructor is much more commonly used. It's used to set up any initial values of variables if necessary, et cetera, et cetera. Destructors are, we'll cover them, but they're used very rarely. So here's a bit of code that we've got. It's our party animal, and a lot of it is the same as what we've been doing so far. So we have this variable x, and the constructor has a special name, underscore, underscore, init, underscore. Again, we pass in the instance of the object, self. And in this one, all we're going to do is print out that you're constructed. And here's this code that we've had before. And now we have underscore, underscore, del, and then we pass in self. And we'll just print out that we're being destructed and what the current value of x is for that particular instance. So let's go ahead and run this. And so again, this doesn't really do any code up to here. That just defines party animal, but this is the constructing of it. And basically that says, oh, and it really kind of creates these variables, and then it also runs the constructor. And so in this case, this line right here is causing the I am constructed message to come out. Then we do an party, and that says, 1 and 2. And here's an interesting thing. We're actually going to destroy this variable by throwing away an no longer points at that object. An is going to point to 42. So we're going to sort of overwrite an and put 42 in it. And at that point, Python's like, oh, this whole little object that I just created, somewhere it's out here, it's vaporizing it and throwing it away. And so before this line completes, it actually calls our destructor on our behalf and so that message comes out. So we are allowed, as the builder of these objects, to add these little chunks of code that says, I want to be involved at the moment this object is created, and I want to be involved at the moment that this object is destroyed. Now, in this last line, AN is no longer a party animal. AN is now an integer. It's got a 42 in it. It's gone. It's been created, it was used, and then it was destroyed. Okay? So you got to be careful. If you overwrite something, you sort of throw the object away. So the constructor is a special block of code that's called when the object is created to set the object up. So we can create lots of instances. Everything we've done so far is we make a class and then we create one instance, one object. And each of these objects end up being stored in its own variable. We have a variable AN and we've been using it. But the more interesting thing begins to happen when we have multiple instances of the same class sitting in different variables. And it has its own copy of the instance variables. So let's take a look at this. So this code here, I've taken out the destructor, and it shows a little bit more information. So now we're going to put two variables in here. We're going to have a current score or whatever, and a name. And we're going to start it out as blank. And this time we're going to add a parameter onto the constructor. And so the self comes in sort of automatically as the object is being constructed. But if we put a parameter on the constructor call, which is this party animal call, then this comes in as the z variable. And so self is the object itself, and z, this first parameter, is whatever parameter we put here. Everything we've done so far has no parameter here, but now we have a parameter here. And then that means that when we call this constructor, this line of code comes, and then name is no longer blank. Name is going to be Sally in this particular thing. And then I'll say, oh, self.name, which will be Sally, has been constructed. And so then we have this, and that object is now constructed, and then we put it in the variable s. And then we call the party method on that, and we construct a different one. And so this time it calls, and z is Jim, and we basically have another copy of this. And so this is how it's going to look, right? As it runs down here, when this is called, it makes one instance and stores that in the variable s. And there's a variable x in there, there's a name in there, there's an init method and party, and that's all in here, right? All that stuff is in here. And now we say, let's make, and that's going to have a Sally in there. All right, Sally in there. And then we're going to do another constructor, and so it's going to make a whole new thing, and it's going to store that in J, and this one's going to have Jim in it. On S party, then this turns into a 1, and then we're going to call J party. That turns that into a 1, and then S party will cause this to be a 2. Okay, and so what happens is we have now two objects, one in the variable S and one in the variable J, and they have separate copies of their instance variables. These are the instance variables or the object fields or whatever, but they're the variables. But the key is that every time we do a new construction, it duplicates this, and there's another copy of it. So there's an x within s. So s.x is this variable, and j.x is that variable. Okay? So the next thing we'll talk about is inheritance, and that's the idea of taking one class and extending it to make something new. So the last topic we'll talk about here in object orientation is the notion of inheritance. And this is a form of code reuse, and it's one of the more advanced aspects of object-oriented programming. So just kind of understand what it is at a high level, and then you know where to come back to when you need to learn a bit more about inheritance. So the idea is, instead of making a new class from scratch, we actually make a new class by starting with an existing class. We are extending it, or another word for this is subclassing. And it's sort of a situation where you're like, I've got this code and I've got this data, and I just need to add a few things to it, and then I'll have a whole new thing. And as you design objects and what we call object hierarchies, you often do this. And it's a form of sort of real clever code reuse. But again, don't necessarily think that you're supposed to know when to use this or why to use this. Right now, it's just terminology, okay? Just terminology. we have what call these as parent-child relationships. The original class is called a parent, and the new class is called the child class. So subclasses are another word for this. You have a class and then you subclass it. I think extending and inheriting and parent-child are probably better ways of expressing it than subclassing. So here's a bit of code. Let's take a look at this. This code's unchanged. It's the party animal code that we've been saying all along. It's the one that we construct and put a name in. And now what we're going to do is extend it. And so you'll notice that this code down here is the part that's doing the extending. So we're making a new class, football fan, and by putting in parentheses before the colon, party animal, that says football fan inherits everything that is party animal, meaning the X, the name, the init, the party, all those methods and data are sitting there. And now we're going to add a new variable. So football fan has, in addition to all those other variables, it has points and it has a touchdown method. And, you know, self points is added, you know, we add 7 to the points and then we call the party. And that does that. So this is calling this method because football fan includes X, name, and party, and init, and everything, and all this stuff, this constructor. So this football fan is really an amalgamation of all these things together. Party animal is just this stuff, right? And so we still have 2 classes. We don't just have one. We didn't erase the party animal class. And so if we take a look at the code that we can run here, we can say, oh, okay, let's make a party animal, Sally. And so that constructs an object like this and then stores that in S. And with an X starting out at 0. And then we call S party. Oops, better change that color. Starts out at 0. And then we call the party method and that changes it to 1. Okay, and so this bit of code, it's as if this part doesn't matter at all because it is a party animal, it's not a football fan. But now if we take a look at this code down here, take this code down here, we're going to construct a football fan and pass in Jim. But football fan has no underscore init, so that actually uses the underscore init from party animal because we extended party animal to make football fan. So we inherited all of the good that was in there. So there it's going to make a name, a variable X, which is going to start at 0, a variable name that's going to have Jim in it, and a variable points that's going to have a 0 in it. So this J variable has more things in it than the S variable has. And so we can call the J party, and if we call J party, that goes here and adds 1 to X, right? So that adds 1 to X. And then we call J touchdown. Well, that comes down in here and adds 7 to the points, right? And then calls party within us. And so self.party is the current object, i.e. self and J are the same thing, right? Self.party. And then it goes up here and passes self in and it adds 1 to the X, in this case of this J variable. So this becomes 2. And that's where it prints out, you know, 7 and 2, and away you go. And so it's a way for you to kind of take all this stuff and stuff it into a class by making a new class and just add the extending bits, the bits that are in addition to the other stuff. So like I said, inheritance is a powerful and wonderful concept. It's a form of, excellent form of reuse, but basically, the whole purpose of this lecture was so that I could in the future just use these words and you would understand them as compared to, I just want to say method. And I've been saying method all along and it's high time that I defined it. So let's just review one last time. Class is a template. It is not actually a thing, it is a shape of a thing. And we define it and say when we make one of these things, it's going to have these variables in it, it's going to have these methods in it. Attributes, variables within a class. Method is a function that's inside of a class. Object is once we construct a class, we get back an object. And so object here is the snowman cookies. Class is the snowman cookie cutter. And a constructor is a bit of code that sets up our object, our instance, when it first is created. And inheritance is this ability to create a new class, but take all and import and affect all the capabilities of an existing class. So, object-oriented is awesome. For the rest of this class, we're not going to write any object code. We're not going to use class at all, but we are going to use objects. And literally, you've been using objects from the beginning of this course. As soon as you said print, whoops, as soon as you said, x equals high, that's an object. And as soon as you said x dot upper, you were calling a method, right? You've been calling a method all along. When you're doing something like fh equals open, this thing you're getting back, that's an object. And then you do fh.read or whatever. You're calling a method in the dot operator. So you've been using objects all along. I now am just finally explaining to you when I say call the read method or call the upper method or what's this little dot and why is that there? So again, it's time for us to understand that, but it will take you a long time before you encounter a problem that's large enough where as part of your solution, you're going to make a new object. But when you do, it's really a powerful thing. I mean, it's a really bad idea for me as a teacher to say, oh, write a bunch of objects. It's like, it's premature for that. It's later is when you will actually learn how to use objects and you'll be like, oh, thank heaven that these objects are here. Okay? So, that's all for now. Thanks for listening. See you on the net. Hello, and welcome to our chapter on databases. We're going to learn a lot in this chapter, learn a whole new programming language, SQL, and learn how to use that. So you're going to need a new piece of software to run all of the exercises that I'm going to do called SQLite Browser. We're using a database called SQLite. Go ahead and download this. You might have to pause and come back if you like. Go to sqlitebrowser.org and download it and install it. While you're doing that, we'll talk a little bit about the history. So in the old days, 1960s, 1970s, I started doing computing in 1975. We didn't have a lot of storage. I mean, this is, 16 gigabytes right here, and, we didn't even have megabytes. I mean, the computer I had a few megabytes of stuff. So we didn't have a lot of disk drives, and so permanent storage was often sequential. And these tape drives that we had, tapes and tape drives were the scalable part of storage because you could just make more tapes and you could rack them up, and so that was our way of greatly increasing the storage of the computer. The problem they had is they were sequential. You read it, it advances, read it, advance, read and advance. Now, interestingly, we've been writing programs that do this, that everything we've written so far pretty much reads the whole file, reads the whole web page, reads this, everything we read it either a loop or read the whole thing. And that's because we have plenty of memory, but we're still reading sequentially. And so the way you would do this when you didn't have enough spinning storage or online storage is you'd use offline storage, but the trick would be that you would sort it. So let's imagine that you're a bank and you have a bunch of accounts, only a few of which are active on any day, and you have a tape that has in account number order from low to high the prior balance, last night's balance of every one of your bank accounts, and then you do all the transactions and you record how much money was taken in or out for each account number, and then you sort those transactions. And then what you do is what we call a sequential master update, and that is you would write a program that would read the first transaction and hold on to it. Say, okay, this is account 45. Then it would read the first account, like 1, and it would copy 1, and then it'd read 2, and read like 7, 8, 42, 43, then it would read like 44, and then we'd read 45, but it would change that and write the new 45 and read the next thing. And so this might be 60. And then it would read a bunch of stuff and copy a bunch of stuff. And then it would finally get to 60 and it would merge the add or subtract. And so the old balance ended up here and the new balance did here. And you had to only make one pass through the data. So it was super efficient. So we had all these mechanisms to sort. We used to do punch cards and have sorters and all these things. And then those things would run for hours. And if you watch old TV shows, these tapes are spinning and these things are running back and forth. These are simply reading and writing tapes. And that's how we did a lot of data processing because we could store far more on a tape drive than we could on a disk. And with racks of tape drives, we could scale the storage that our computers had. And so that's the way we did data processing, but it meant that the only way you knew what the old balance was it was the balance as of this morning before your bank started. You don't know what the balance was for the day, and that led to things like you can never you can never withdraw more than $100 a day or something like that, because you don't know what the old balance was, or you might go withdraw $100 at a couple of different branches, and so they weren't able to look your stuff up right away. Now, it didn't take long until the disk drives got better and better and better, and you could store the entire accounts, all the accounts and their current balances, on computers. And then the problem becomes is, what happens if sort of in the middle of the afternoon you want to update a balance? Well, do you want to read all your data and then write a brand new one? And say that takes like 10 minutes. That means for that 10 minutes, only one person can be updating their bank balance. And so because we could randomly access this data, we didn't have to read it all sequentially. The trick is how do you spread the data out, and then how do you make it so you can change a balance? This is, of course, second nature today, but how do you make it so you change the balance here without changing the balance there, and you can have multiple people going simultaneously to these things, and make sure that you can't say to withdraw money at two different locations simultaneously and somehow have your bank balance get corrupted by that. So there's a lot of debate on how to do that. And in early days, we just did sequential master update, but increasingly we wanted to make better use of the random nature of our computers and our storage. And so that's what led to databases. Databases are the science of how you make use of rotating random access data, permanent data, in a way that allows you to read, modify, and update that simultaneously from many different locations and yet keep the data completely consistent. And so this led to a study of a thing called relational databases. And relational databases are not the only databases that happened. We had many other kinds of databases, and there was a debate. And I remember in the 70s and the 80s, there was folks that says, oh, no, there you could do index sequential. That's the way to do it. And relational databases weren't all that popular the first time that I saw them. I didn't like relational databases. But relational databases had an inherent advantage because they were based on some really powerful mathematics. And the interesting thing is early on, the relational databases were slower, but eventually they figured out how to sort of bring all the cleverness to bear to make relational databases fast. And so relational databases are a pretty advanced technology, and there are companies like Oracle that are very, very wealthy, and their primary product for many, many years was nothing more than a clever database product, a clever piece of software that was really good at solving this problem. And that's how important this problem was to computing. If you read about databases, you're going to see two sets of terminology. One set of terminology comes from the mathematical background and has to do with the underlying math. Things like relations, tuples, and attributes. That's kind of like the fancy math version of it, and programmers kind of think of them as rows and columns inside of a table. And so if you look at sort of fancy theory, you'll see words that look like this, and they're just full of this and the connection. Now, all this is important and true, and if you really want to get good, you sort of begin to understand the nature that we model data at connections rather than at sort of intersection points, rather than just modeling data as a flat file the way we do. But for now, we're going to, as programmers, think of this as just like, oh, it's like a super fast spreadsheet. The super fast part is the math. For us, the rows, columns, and tables are spreadsheets. So think in a spreadsheet of sheets, sheet, and that's like a table, a named thing like tracks or albums, artists or genres. And then there is rows, and each row has a different kind of data. And then there's columns, and we sort of specialize the first column in many spreadsheets to say what's in there. This is not really the data. This is like metadata. It's like the title's in this first column. That's not really the data, and the data starts here. And we have different kinds of data like strings and numbers, et cetera, for each of the rows. And literally, you can get away with this as sort of about 80% of databases is just a really super cool spreadsheet. But under the covers, it is far more powerful than that. So one of the early arguments that happened was, again, what the programming model for this was. And a lot of folks wanted a programming model that reflected how the data was actually stored. The notion of structured query language came about in a way to express what you wanted to happen and allow that to be sort of a very abstract expression. Select all records that meet this criteria, not read. And so structured query language is not a procedural language. It is a imperative language where you're simply saying what you want and then somebody writes the loop. The database actually does the loop, but it's a way for you to avoid actually writing the loop. Now that turns out to be the power of databases, because the cleverness in how to write the loop is a way that you would probably never figure out how to be most supremely optimal when it comes to writing the loop, as you'll see toward the end of joining many tables together and selecting and throwing array and getting down a count or whatever. Someone has figured out how to do that really, really well. So the idea is you would express, you know, we're going to create some data, we're going to retrieve some data, we're going to insert and delete it. Create, read, CRUD, C-R-U-D. Create, read, update, and delete, CRUD. And so that's what this does. It's a language that does this very simply. Now the applications that we're going to use this for are more of a data analysis application. We've been doing data analysis through the whole course. And the kinds of things that we'll see in the remaining chapters is we'll take some raw data file. These might actually come across the network, and we'll write some Python programs to play with that data, parse it, clean it up, make sense of it, you know, and then write it into a database. And this might be a slow process, or this might be really nasty, and this might be a way to have very clean data. And then we'll write another Python program to sort of read through it, and it's all efficient and pretty. And then we can produce files, and maybe we'll visualize it or do further analysis in R, Excel, or a JavaScript visualization framework. And so in this situation, you will be the person who is both sort of writing the programs, database administrator, and you can, using SQLite Browser, play and look at the database kind of in a raw way. And the first part of this, we are mostly going to be using SQLite Browser just to talk straight to a database. Later, we'll write Python programs that read and write data and visualize the data. So this is what we're going to do first, and then second, we're going to do this part right here. That's the second thing we're going to do. Now, another really common use of applications, and something that if you continue learning more about programming, is that you will want to write an online application like Amazon or a company or Twitter that's got a website and it stores dynamic data in databases. And so the picture for that is similar but different than the picture we're going to start out with. And so the way this usually works is that you, the end user, uses a web browser, talks to the application, and the developer writes the application software, and that application software stores its data in a database, and inside that database we talk to the database using SQL, and all the data is actually stored here, and the magic happens. The data server is that database software that's so precious and valuable. And then there's another person, often called the database administrator, who has direct access to the data. And these roles in medium and large projects are kept separate, mostly because the production, while it's running and live, the developer leaves the data alone and works on, say, the next version of the software. And then the developer has a test version of the application that they run on their computer where they're doing all that stuff. And so this database administrator is a role in a large project where we have to run production and keep production careful, keep production in good shape. So the database administrator has this responsibility for the production aspects of the data, and you may be working in a situation where you're not actually controlling the data. The database server is on different computers, you have little special access, and you write programs to sort of read the data, and so the database administrator is the person who is asked by the organization to administer that data. The data that we develop, and we'll do this in the second part of these lectures, conforms to a data model. That's the metadata. Is this an integer? Is this a string? You know, how many columns is this? And the data model turns out to be very, very important. And there's a lot of science to building an effective data model that leads to really good performance. And it's a collaborative activity between the application developers and the database administrator to make it so it's efficient, runs in production, etc., etc., etc. There's a lot of products out there that you may encounter. We're going to be using SQLite. SQLite's a little tiny database server, and it's built into so many things, and that's why we like it. But if you're going to work at a large organization, you could easily run into Oracle, which is the #1 commercial product. Microsoft has a thing called SQL Server, which is a commercial product, and it's also very popular and very effective. The more popular open source, there's things called Postgres, there's MySQL, and MySQL recently was sort of bought by Oracle, and there is a copy of that called MariaDB that doesn't belong to Oracle, MariaDB. And so most of the SQL that we're going to learn is common across these database systems because SQL is a standard, but then there are parts that weren't part of the original standard where each database vendor has done things a little bit different, but there is a core common subset that does the basic create, read, update, and delete operations. So SQLite is very popular. You probably have it in your cell phone 10, 12 times. Your web browser has a database engine in it. Your car has a few databases in it. And so SQLite is what's called an embedded database system. Python comes built in with it. You just import SQLite 3 and away you go. And so it's very, very popular because it's free, it's open source, and it's such a tiny little piece of software that you just include it in other pieces of software and use it to solve the data management problems of those pieces of software. Like your browser might use SQLite to store your bookmarks. Now you think, oh, there's only how many bookmarks can you have? But what if you need it to be fast? And what if there's like people that have 10,000 bookmarks? There probably are. Do you still want it fast? Do you want to be able to search? And so you get all that by using a database like SQLite. And so again, we're going to encourage you to download the SQLite browser so you can follow along with what we're going to do coming up next. And so here is the SQLite browser. Here's what it looks like. And it's just a desktop application. And coming up next, we'll start playing with this desktop application and see how it works. So now we're going to make a database. We're going to use SQLite browser. Hopefully you've downloaded it so you can follow along. And I've got this handout, this basic database handout that saves you from having to type all these things. So bring that up in your web browser. And so that gives you all of the commands that I'm going to type now. And so you could pull them out of the either the web page, you can pull them out of the slides, or you can pull them out of that. So I'm going to bring up the database browser here. Database browser. Now the thing that's going to happen, you'll see this happen on my desktop. I'm going to make a new database, and you have to store it somewhere. And so I'm going to put it on my desktop, and I'm going to call it py4e fun. And so we should see a new file on my database right there, py4e fun. Now that's a file that you don't want to edit with a text editor or anything like that. This is a database that this is a file that's to be read by SQLite browser and nothing else. Okay, so we're going to create a table, and I'm going to make a table called users with a column called name that's a text and a column called email. So it's already asking me to make a table. I'm going to call this users, and I'm going to add a field that is called name, and I'm going to add a text, and I'm going to add another field called email, and I'm going to make that be text. Now the key thing here is we are in effect making columns and rendering an opinion as to exactly what that column is supposed to be used for, and we're not allowed to violate that. It's not like, oh, we'll do whatever you want, because the database is optimizing its storage based on a contract that we're effectively making the contract ourselves. We could make these columns anything we wanted, but we're going to contract with ourselves. And you can see it's kind of small here. You can see there's a create table, and that's on the slide, and that's the SQL way of doing that. This user interface is just helping us write SQL. So now I'm going to just say OK, and if you take a look, you can see that I now have a table users, and I can look at my database structure, the table users, and away we go. And so now that is creating it, and like I said, here in the slides is the create statement, or on the web page there's the create statement that could have done it. Now we can insert some data. Let's add a new record to this database users, and we'll call this guy name Charles CSEV at umich.edu. So now we have a record. So it's kind of like a database, a spreadsheet. Now that's not the SQL way to do it. There's SQL sort of going on in the background. But if we really want to do this using SQL, we're going to use the insert statement. And the insert statement looks like this. The SQL syntax sometimes has extra words. Insert into is actually two SQL keywords. The name of a table, the columns, and then the word values, and then one-to-one correspondence between the values and in parentheses. So it looks kind of like a tuple in Python, but we're nowhere near Python right now. Okay, and so that's what we're going to do. And so I'm going to grab this Kristen, and I'm going to go over here to my SQLite browser and say execute SQL. So now I can say paste that in and then hit this little run button. And that's going to submit the SQL to SQLite and then update that file. And it says query executed successfully, and away we go. So if I go back now and I look at the data, I see that there's two things in here. And now I can actually insert all the rest of these. Let's go back to my little bit of stuff here. Let's put all these other rows in. It turns out that if I go into the execute SQL and I want to do more than one command at a time, I can put a semicolon at the end of each one of these things, and then I can run them all all at the same time. I mean, one after another actually is what's going on here. So boom, 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 and now I take a look at the data, and look, I've got all those things in there. Now, eventually, the thing that's going to generate that SQL is a program, not us. We're being the database administrator, so we're sort of doing things manually. Once things get going, you write programs, do that insert over and over and over again in Python or a web language like PHP or something like that. And so that is the insert. Now we can get rid of data. And so I'm going to say delete from, that's the keyword, users is the name of a table, where is a where clause. We'll have lots of where clauses in SQL, which is, it's not like an if, in effect the delete is going towards the whole table and being turned on and off by this where clause. So delete from users, if you didn't put the where clause on, will actually delete all the rows. But where ted equals, email equals ted@umich.edu, well, that one is going to make it so it only applies to the rows where that is true. So I'm going to go over here in SQL, and I'm going to say delete from users where email equals ted@umich.edu, and then I'm going to run it. Because it's only one, I don't need a semicolon at the end of it. And now if I go back and I look at the data, Ted is gone. Okay? Update. So the update says, updates keyword, users is the name of the table, set is a keyword, and then this is column equals new value, and then a where clause. Again, this update, if we didn't have a where clause, would change every row in the table. And so where email equals csev@umich.edu. Oh, I got to change that because I already got the name to be Charles. So you see the name is already Charles. So I'll just execute here. Make this be Chuck so we see it. And then I run it. And then you take a look at the data and it's changed. That's it. That's an update statement. You're doing great. You're doing great. And so the next thing we're going to do is we're going to take a look at how we retrieve data. Now this is the select statement, select star. You have a list of columns, and star means all columns. From is a keyword, and then the name of a table. So this select star from users is the kind of thing you type all the time. As a matter of fact, it's what SQLite Browser is doing internally to cause this to happen, but we can do it by hand by saying select star from users and then run it. And so then we get a little record set that is those 4 records that are sitting there. We can also throw a where clause on the end of it. So we say select star from users where email equals csev@umich.edu, and that, again, the select star from users goes at the whole table, and the where clause goes at the whole table and then filters out all of the things except one record. So the where clause is send it to the table, but then filter based on whatever, and so it only shows us that. Okay, we're cruising right along here. You can also put an order by clause on there. So we can say select star from users, order by email, so that's a column. Select star from users, order by email. And so that orders by email. Or we can change it to name, and we can say descending. So that's the name in descending order. Sorting and selecting are good things that databases are really good at. So this is the summary of what I've told you. I said the databases do create, read, update, and delete, CRUD. And we've done all those things, except we did create, delete, update, read. That's what we did. And that's the summary of SQL. And so you might be saying, why did I take so long to learn such a simple and elegant and beautiful language? Because it's not really exciting. It's a extremely simple language that's very predictable. And you're like, well, that's pretty easy. And it turns out that some of you may have been using SQL in situations, maybe with Microsoft Access or something, where you're actually typing this stuff and you just kind of typed it and you never realized that you were learning a programming language. That's why I like SQL, and that's a very declarative language and it's very straightforward. It's much harder to learn. It's much easier to learn SQL than it is to learn Python, because in Python you have to figure out how loops work and how iteration variables work, and you'll notice there's none of that. And so but the key is we've only started to understand the power. That's the simple ability to move around and update data and read data randomly using these simple sets of commands. But up next, we're going to look at how you do this with data models and relationships and really multiple tables. Hello and welcome to a code walkthrough. In this bit of code we're talking about the emaildb.py. This is a beautiful little example in that it sort of reduces talking to the database to kind of its pure essence. And so we'll start out this code and we import the SQLite 3 just to get the library there. We make a connection, and in databases we sort of end up with an open that's two steps. There's the connection to the database, which checks access to the file, and the cursor is kind of like our handle. It's not as simple as you just open it and read it, but you open it and then you send SQL commands through the cursor, and then you get your responses through that same cursor. So CUR here is the variable that we're interested in. And the first thing that we're going to do is we're going to we've got this file. It will either create this file, and right now this file doesn't exist. It's going to be in the same directory. Oops, email. Yeah, there's no email DB. So this is actually going to create the file when it runs. And then the first thing we're going to do is drop the table if it exists. Drop table is a bit of SQL. The if exists just keeps this from blowing up if we start with a fresh database. And in this case, there is no file there, so we are starting with a fresh database. So this will accomplish absolutely nothing, which is just fine. Now we're using triple quotes here. I'm just kind of using that to make this a little bit easier to read. I probably could pull those lines up a bit. This one's actually small enough that I could, maybe I'll just do that. Let's do that. Let's bring that baby right up and turn this into a single quote. That's short enough, right? But triple quote is just, this one here is a little longer, so I use triple quote. So we're going to drop table. That's going to do nothing first time through. Then we're going to do a create table. Now sometimes your application will have like a README or something. It says go run these commands to set the database up, but we're able to just set this database up in this particular application. We'll see later ones where we're going to leave the database and not start it fresh. And in this one, we can do the same. And so, but in this one we could, but we're just going to start fresh by dropping the table. So we'll create it. We're going to have a email and an account. We're going to basically, what we're doing here is we're really going to pretend that this is a dictionary. If you recall, when I said dictionary is like an in-memory database. Well, now we're using a database to do a database, but the first thing we're going to do here is pretend it's a dictionary. So that's a little crazy. So these next lines of code hopefully are pretty familiar to you, right? Get a file name, loop through it, check to see if it's grab inbox short by default, so we can press the enter key and then loop through it, right? And so this little part right here, this is our basic loop that we're doing, and so that is pretty normal. And if we look at this line right here, that line right there is the line that is that line right there makes sure that we can only get the from lines. We've done that a bunch of times, and we're going to split it. We're not going to strip the right because the split's going to take care of that. And then we're going to grab the email address, which of course in the from line is the second part, and then we will have that. So now we're going to do some database. So the first thing we're going to do, this bit right here is kind of like the dictionary part. So the first thing that we're going to do is we're going to select count from our database, that is an integer, where email equals. And this part right here bears some explaining. This is going to be c7@umich.edu or whatever. Now, it is dangerous to put those strings, especially from user-entered data, into your SQL. You technically could. I could make this be a email equals single quote c7@umich.edu. I'd have to escape the quotes and stuff. But this question mark is a placeholder. And this is a way to basically make sure that we don't allow SQL injection. Go Google SQL injection to get a sense of what that is. It's more of an issue in online applications, but in this application we're just being good. And so the way this works is this is a placeholder in this SQL that will ultimately be replaced by this. Now you could have several question marks. We only have one in here. And so you give a tuple. And if we just put email, it won't turn into a tuple. This is a one tuple basically. This little weird parenthesis email, comma, parenthesis, that is a tuple with only one thing in it, and that's just the weird Python syntax. It's rare that I apologize for Python syntax, but that's a little bit less than pretty, but it's okay, it's a tuple. And normally if there were like two of these, then there would be email, name, da 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 da. Okay, so this cur.execute is actually not really retrieving the data. In a way, it's looking at the SQL and making sure that maybe it might verify that the table name is right, or if there's any syntax errors, etc., etc. So this actually is not really reading the data. So, but we have prepared this cursor. This is kind of like the opening of a file, but what we're opening is a record set. We're opening a set of records that are going to, be this wherever it's true. So it's like we're going to read this like a file. Now later things will loop through this, but we're only going to say, hey, grab that first one, right? We could have even put maybe a limit clause on there or something. Grab the first one and give it back in row. And so row is going to be the information that we get from the database. And so that is, if there are no records that meet this, then row is going to be none. So here's kind of, again, like the get. Here's like the get, where if the row wasn't there, because the way we're doing this is we're going to end up with this row in the database. Here's this database, and there's going to be two columns, and there's a bunch of rows. And then here's going to be CSEV 4 and Jen 3 and Stephen 6, right? So these are the counts. And so we're grabbing this variable out, if it's CSEV that we're grabbing, and that's going to come into here, right? That's going to show up in here. And that row is actually, it turns out that the row is a list, but we're only getting one thing. And what we really are doing is if we search through and we got through and there was nothing, then row is none means that there was no, and we're seeing like Chen's for the first time, and we have to insert it. So if row is none, we're going to run an insert statement, insert into counts, email count. Now we've got to set it to 1 because it's the first time we've seen it. So values, and then again the question mark. The question mark basically says, hey, I'm going to have a value in this tuple, and there's an ordering to the tuple, and so there's only one question here, one question mark placeholder here, and then 1 is the initial count. So email question mark count 1, away we go. And so then we have a tuple that gives to this execute statement, just like in that execute statement, the corresponding sort of strings or integers that are to be replaced by each of the questions. So when this runs, there's going to be a new record, and there's going to be a 1 that's put in there into that new record. If, on the other hand, we pull back a row that exists, we're going to get this 4 number. And you might think we want to take this 4 number and add it, but in databases, it's always better to do an update because there might be multiple applications that are talking to this database at the same time. So no matter what update does is in a single atomic operation, it turns whatever this number is into 1 higher, and we don't have to worry about other pieces of code potentially modifying it. Now in this case, we don't have to worry about that because we're the only piece of code, but using update to increment something is way better than reading the value and then doing an update to adding one inside of Python and then updating the new value, that's two SQL statements, but it's also not atomic, okay? So if the row is none, if the row exists, we just know that it exists and we just want to add one to the number. We do have the number sitting here in the row variable, but we don't need it. And so we're going to say update counts, set count equals count plus one, column name, where email equals, and then another placeholder, and then another tuple for the question mark, okay? And so that's what this little bit of code does. That is kind of the read it, parse it, check to see if it's there. If it's not, insert it. If it is, update it. And so then we see this con commit. And this con commit, basically the way it works is that the database is efficiently keeping some of the information in memory, and at some point it has to write all that stuff out to disk. So you can choose at times where you put this commit. Right now we're going to commit every time through this loop, but you might commit every 10th time through the loop because the commit will take some time because it forces everything to be written to disk, and these can run really fast, and the commit is the slowest part here. So sometimes we do things like commit every 10th record or every 100th record. If it's an online system, which is not what this is, you have to commit at the end of every sort of screen paint. But for this kind of a system, because we're putting so much in, this is kind of a bulk insert, we might come up with a thing where we, every 10th time we do a commit. But ultimately what this will do when this is running is it will build up slowly but surely, adding new records, and then 1, 1, and then it'll be a 2 and a 3 and all these things, and add another one, that'll be 1. It'll do this thing, right? And then at the end of the day, that is what's going to be in the database. Now, so let's take a look what's in the database, and now we can actually read the database. And so in the database, we're going to run a select, and we're going to select the email and the count from counts, order by count, descending. So look at that, isn't that cool? We're getting in the top 10 because databases are good at sorting and they're good at all these other things. So we're going to then execute this, and then we're going to ask for the rows one at a time, and the rows are going to be row sub a tuple, and row sub 0 will be email and row sub 1 will be count. So we run all this stuff and then we close the connection and away we go. Okay, so let's go ahead and run this. Let's go ahead and run all this stuff. Python 3 email db.py. It asks for a file name, mbox short. Well, I can hit enter, right? Mbox short. And that's it. And it looks just like that, and it counts it, and away we go. Now the difference is, at this point, we have a file, emaildb.sqlite. And we can run the SQLite browser, and we can then open this database, and we can see what's in there. So here we go. It is made an SQLite database. We have a table of counts, and then we can take a look at the data, and there we go. We've got the data and we can do this. And so let me close this. It's important at times when you don't want necessarily to have, well, let's see if we can cause it to lock up. Let me run this again, and it's going to drop this table. So I'm going to run the code again. But this time, I am going to do the full one, mbox.txt. Now, we'll see what happens here. But it ran. And now, so what we have to do then to see this data is from the previous run, but if we want the most recent one, we hit refresh, and then away we go. And so we can see this stuff. And so this is just a real simple start to see how you can connect some of the stuff that we've been doing, but store the data in a database. But the nice thing about the database is that it can store this stuff from run to run. Even though in this case, we're dropping the table every time, in later things, we will see how we can store data from run to run to give ourselves more restartable processes. Cheers. We're going to do some code walkthrough, and if you want to follow through with the code, you can download the sample code from Python for Everybody. And so the code that we're going to play with is the Twitter Spider code that is both talking to the Twitter API and talking to the database. And so what we're going to be doing